All right, here we go, mathletes. So, section 2.2, we'll send a couple days here, but today we're going to talk about what is a limit. All right, and a limit is something in math that is it's kind of an interesting concept because, or an interesting topic, because what we're trying to do is we're trying to figure out, okay, as our approaches a certain value, what is our output approach, right? So, for example, in this case, or in let's say the case of the first graph here on the left, A, we have this function here, right? Here's the algebraic representation of that function. Then we have our graphical representation. So here, like for example, I have a point that doesn't exist. I have an open circle there. So I can't just say what is f of 2, right? Because that does not exist. It's not defined at that particular point, right? So we don't know what that value is. But what we can do is we can say, well, as we approach that point from the left, as we get closer and closer to 2, right, from the left. So if I plug in values like, 1.9 or 1.99 or 1.999 or 1.99999, right? And so we can play that game forever. But as I get closer and closer from the left with my input, what is the output, right? Is what I'm asking. And same thing, I can do the same thing from the right side. As I plug in values like 2.1 or 2.01 or 2.001, right? As I get closer and closer from the right side to 2, then what does the output equal, right? And so that's kind of what we're looking at with limits, is we're saying, hey, as we get super, super close from either side of that input value, what is our output going to be? Okay. All right. And this may or may not click right away. So don't, if, just kind of keep letting it soak in. And and as you see, kind of different ways to evaluate limits and different ways to think about limits. We'll spend a good amount of time on this, and so just kind of be patient with yourself as far as understanding this concept, because it is a little different than things you may have done before in math. So, all right. Anyway, so here with the second graph here, the B function, we can see that as we approach 2 from the left, we get a different output than as we approach 2 from the right, right? And so that's a thing sometimes a limit. Sometimes you don't approach the same output. Sometimes you approach different values from either side, okay? And we'll talk about what that means. And then finally, the graph on C, we can see as we approach 2 from the left, looks like this graph is going up forever, right? And as we approach from the right, same thing, it's going up forever. And so we can have infinite limits as well. And so we'll see situations where the limit as x approaches 2 may be infinity, right? Or maybe negative infinity. All right. So that's what a limit is asking, what as we approach a certain input, as we get super, super close to a certain input, what is the output at that particular value as we get close to that input. All right. So here's the formal definition from the book. So let f of x be a function defined at all values in an open interval containing a. Okay. So a is just a value that's in that interval, with the possible exception of a itself. So basically a itself may not exist in that interval, but a is included in that interval. Okay. So the function may not exist at that point, but a is in between that, between the two endpoints. And let L be a real number if all values of the function approach the real number L as the values of x approach the number a, right? So in other words, as we approach a, then the limit is whatever L is, right? Then we say that the limit of f of x as x approaches L. All right. So another way to say it is, as x gets closer to a, like we said, right? As the input gets closer to a, f of x, the output gets closer and stays close to L, okay? So this is the notation that we'll use. And that's how you would say this. Is you would say the limit as x approaches a, okay, that's how you would say this right here, the limit as x approaches a, right? And actually you'd probably say the limit of f of x, right, if you have that function there. So the limit of f of x as x approaches a, and then you could say is L, okay? All right, so remember that a is an input value, okay? So this is an input, and your result is an output, okay? So what you get here is an output. All right, so basically, you know, if we're looking at a graph, this is our x value, right? And our output is our y value. All right, so that's what a limit is. Once again, you know, be patient with yourself. If this isn't totally clicking yet, just give it a second. Let's see some examples and things like that. You know, maybe it might take getting into class and asking a few questions. And so, yeah, and if this is something where you're like, oh, that makes sense, then that's great. You're ahead of me when I was learning this. So, good work.